Bismillah ar-Rahman ar-Rahim. My name is the lecturer Hamid Hudwan, University of Babylon, College of Engineering Al-Musayyib, Department of Automobile Engineering. This lecture today entitles of absolute or primary instruments and secondary instruments. This belongs to Department of Automobile Engineering and Department of Energy Engineering of College of Engineering Al-Musayyib, University of Babylon. We completed the classification of measuring instrument and we reached to the final classification. It's called absolute or primary الأجهزة المطلقة أو الأجهزة الابتدائية لأنظمة القياس والأجهزة الثانوية secondary instrument. The absolute instrument, this instrument gives the value of the electrical quantity in terms of absolute quantities or some constants of the instrument and their deflections. They are mostly used as means of standard measurements and are maintained by national laboratories and similar institutions. Examples of absolute instruments are tangent galvanometer and relay current balance and absolute electrometers. Secondary instruments, they are direct reading instruments. The quantity to be measured by this instrument can be determined from the deflection of the instruments. They are often calibrated by comparing them either with some absolute instruments or with those which have already been calibrated, and some of very widely used secondary instruments are ammeters, voltmeters, wattmeters, energy meters, watt-hour meters, and this belongs to the batteries, and ampere-hour meters. Also, it's useful for to rate the batteries. Batteries for everything, for houses or for vehicles, or for cars, for anything. And the classification based on the various effects of electric current or voltage upon which their operation depend on their magnetic effect used in ammeters, voltmeters, wattmeters, integrating meters, and heating effect used in ammeters and voltmeters, and for chemical effect used in DC ammeter ampere-hour meters. That is usable in batteries, as I said before. Electrostatic effect used in voltmeter, electromagnetic induction effect used in AC ammeters, voltmeters, wattmeters, and integrating meters. Generally, the magnetic effect and the electromagnetic induction effect are utilized for the construction of the commercial instruments. Some of the instruments are also named based on the above effect, such as electrostatic, voltmeter, induction instruments, and so on. The classification based on the nature of their operation, we have the following instruments: indicating instruments. Indicating instruments indicate generally the quantity to be measured by the means of a pointer which moves on a scale. Examples are ammeters, voltmeters, wattmeters, and etc. Recording instrument, اجهزة التسجيل. These instruments record continuously the variation of any electrical quantity with respect to time on a chart or dial. And integrating instruments اللي هي الأجهزة التكاملية. These instruments records the consumption of the total quantity of electricity, energy, and so on during a particular period. No indication of the rate or variation or the amount at a particular instant are available from them. Some widely used integrating instruments are ampere-hour meter, kilowatt-hour meter, and kilovolt ampere-hour meters. And third classification based on the kind of current that can be measured: direct current DC instruments, and alternating current AC instruments for direct current and alternating current instrument DC and AC instruments. Classification based on the method used direct measuring instrument. This instrument converts the energy of the measured quantity directly into energy that actuates the instrument, and the value of the unknown quantity is measured, displayed, or recorded directly. These instruments are most widely used in engineering practice because they are simple and expensive. In addition, time involved in the measurement is shortest. Examples are a meter, voltmeter, and wattmeter, and so on. Comparison instruments. This instrument measure the unknown quantity by comparison with a standard. Examples are DC and AC bridge and potentiometers. They are used when a higher accuracy of measurements desired, and the classification based on the accuracy class of instrument. To choose the instrument most suited to a particular measurement application, we have to know the system characteristic. The performance characteristics may be broadly divided into two groups, namely static and dynamic characteristics. الخصائص الستاتيكية والخصائص الديناميكية. نأخذ أول خاصية bandwidth. The bandwidth of an instrument related to the maximum range of frequency over which it is suitable for use. It is normally quoted into terms of 3 dB. dB تعني decibel point for an amplifier. It is the range of frequencies. Amplifier تسمى أحيانا المضخم باللغة العربية, between which the gain or amplitude ratio is constant to within 3 decibel. This corresponds to 30% reduction in gain. الخصائص الستاتيكية, static characteristics, the performance criteria for the measurement of quantities that remains constant or vary only quite slowly. And dynamic characteristic, the relationship between the system input and output when the measured quantity is varying rapidly. Rapidly يعني بصورة مفاجئة أو بصورة سريعة متسارعة متصادمة. Static characteristics, الخصائص الاستاتيكية توجد 14 خاصية. There is 14 characteristics, static characteristics for instrument. First of all, accuracy, precision, sensitivity, resolution, impedance, range, span, hysteresis, and backlash, instrument drift, linearity, threshold or dead space, stability, tolerance, and bias. Dynamic characteristics, الخصائص الديناميكية توجد 5 خصائص. طبعا هذه موجودة في أغلب كتب السيطرة وكتب أجهزة القياس. Speed of response, and which are the speed of response, fidelity, lag, dynamic error, and frequency response. Static characteristics, which are accuracy, it is defined in terms of the closeness with which an instrument reading approaches the true or expected desired value of the variable being measured. Second, precision, it is the measure of the consistency of reproducibility, repeatability of the measurement. In other words, the successive reading do not differ for a given fixed value of an input variable. Precision is a measure of the degree to which successive measurement differ from one another. يعني تختلف من واحد إلى آخر. Sensitivity, طبعا لدينا خصائص متقاربة بالتعاريف اللي هي الأكيوراسي والبريسيشن والsensitivity والresolution. These are 4 static characteristics are near each other. It is sensitivity and حساسية is defined by the change in the output or response of the instrument for a unit change of input or measured variable. And resolution is the smallest change in a measured variable or measurement to which the instrument corresponds. Static characteristic impedance in the ideal case. The act of measurement should not alter the value of the measurement signal. Any such alternation is a loading error. Loading errors can be minimized by impedance matching of the source with the measuring instrument. Reduce the power needed for measurement the power loss through the measuring instrument, where Z of omega is the input impedance of the measuring instrument and E voltage is the source voltage potential being measured. To minimize the power loss, the input impedance should be large. P power equal E squared divided by Z. Thank you for attention. Any question you can text me.